Hello, this lesson is on translating functions. So today we're going to learn how to move functions around. And that's exactly what a translation is. A translation simply slides a graph right or left, and or up or down. So you might have a parabola, quadratic function, when you graph it as a parabola, and then you can move that this way or this way, up, down, and just slide it. So maybe it ends up down here and to the right. So that's what we're going to learn how to do today, is how do we slide these. So we'll review a little bit about how this worked when we did this with quadratics before. So from last year, vertex form looks like this. F of x is equal to a times the quantity x minus h squared plus k. And when you slide things around, the h value and the k value do a couple of different things. So this h value is a horizontal translation. What that means is simply means I'm going to move it right or left. And then the k value was the one that went, hey, we're going to move this up or down. Now, you'll notice here that there's a minus sign right here, and that then is going to kind of change things opposite of what you might think for horizontal translation. So in here, I'm just going to write opposite. So if I look inside the parentheses here, that is what is being squared. And whatever's inside the parentheses is going to be your horizontal translation, okay? So this means right or left. Well, when you see plus 2, you normally think, well, that's to the right too, because positive is to the right. But it's not. It's actually left 2. And the reason for that is my h, I can rewrite this. If I want to rewrite this with a minus sign, so that a minus sign is right there, so that it looks like this one up here, you'll notice I have to write it like x minus negative 2 squared. And then my h is negative 2, which is why it moves it to the left. So, but a lot of times it's just easier to think of this as just like an opposite translation. So that's how I think of it. It just goes a little faster that way. So this moves it to the left, 2, and then this outside of the parentheses is going to move it up or down. And because it's minus 3, this one is just normal. So this would be and down 3. Now you might also recall that this thing, the negative in front, is going to turn it, reflect it across the x-axis. In other words, turn it upside down. The 4 represents a vertical stretch by a factor of 4, so that'll actually make it skinnier. If we were to graph this, it would look like this. I did this already. So here in green is our parent function, y equals x squared. And then in purple, you can see the one graph has been moved to the left 2 units and then down 3 units. And then also it's been flipped upside down, and it's also a little bit skinnier. But notice it is been slid left and then down 2. So we call those translations. So that's how that works for quadratic functions. Now the reason we're going over that is because this works for all other functions as well, or most other functions, I should say, in a very similar manner. So translations. We can slide any functions in the same way we did with quadratics. So that's why we just talked about that. So vertical shifts. You're going to look outside of parentheses or absolute values or brackets or whatever. If it's outside, that number is going to move it up or down. So if it says f of x plus c, that's going to move it up c units. If it says f of x and then minus c, then it's going to move it down. For horizontal shifts, again, this will be opposite of what you might think. So you're going to look inside the parentheses or brackets or absolute value signs or whatever. And if it's in there, then it's going to move the graph left or right. But if it says x minus c, that's going to actually move it to the right. If it says x plus c, it's going to move it to the left. So kind of like opposite of what you might think, just like we did with quadratics. All right, so let's look at these two graphs. It says graph the translation. Here's f of x, and we want to graph the translation f of x plus 3. Since this is outside of parentheses, we're just going to move it up then, right? So what you want to kind of do is look at your graph, pick some vital points like that one, and you're just going to move them up 3. Here's another one, so I'm going to go up 3 from there, and then kind of do the same thing there. All right, so now well, that's not very good. So I want to try to make it look a little bit like that, but I did not do a very good job. So that's okay. Just try to, sometimes it's easier to try to do the middle part first. And do the best you can with that, just so it looks somewhat similar. That doesn't look great, but you get the idea. You're moving it up or down. It says here, graph the translation g of x, and then minus 5. So this is the same thing. I'm just going to shift this down 5, but I do want to still pick some vital points. You'll notice here, there's one here and one here. So I want to do that same thing. So I have that's better than my first one. Okay, so that just moves the graph down. You'll probably do a better job on your paper than I will on my iPad, but this works for horizontal ones as well. So this one says graph the translation j of x minus 6, and then graph the translation of h of x plus 2. So this is inside the parentheses. So that minus 6, I normally think to the left 6. I'm going to go to the right then, because it's going to be opposite. And that's kind of a important point. It looks like here would be another one. So something like that. It's been moved to the right. This h of x plus 2, that's going to mean then to the left 2. So I'm going to go left 2 units and go up. There we go. So that's how you slide the translation left, right, up, and down. So now really, how do you put it all together? So you might see both of these together. So graph the translation m of x minus 2 plus 3. So this function is our square root function. And we're just going to move this up 3. That's what this means, up 3. And this is going to mean to the right 2. So pick some points that seem like they would be good ones and relatively easy ones to do that with. So maybe those 3 points. So I want to move those 2 units to the right and then up 3. So that would be my first point. There's another one. Okay, there we go. All right, and then this one says graph the translation of w of x plus 5 minus 4. So this, I should think, okay, that's left 5, and this is down 4 units. So a couple of translations there. So those points I think are the ones I want to try to do here. So I'm going to go left 5, down 4, that's the middle. And then here's the other 2. Now I have a feeling this one is going to be a little tricky for me. Okay. I think I maybe need an Apple Pen or something. This is a little tricky to draw these graphs, but there, you get the idea. Okay, so here's a reminder of our parent functions. We've got the linear, quadratic, cubic, absolute value, square root, and exponential functions. So now we just want to be able to write a function using these as our kind of guide. So writing an equation for each one. So I notice this is the absolute value function. So this is that, and this is my square root function. Okay, so I'm just comparing that, right, with these right here to kind of get that information. I have here and here. So now these are not it's not the parent function, they've been moved. Let's take a look at how they've been moved. So this one has been moved. This first one here, it's slid to the left 2 and down 1. So I'm gonna write that over here. Left 2, down 1. Okay, so if I want to slide it to the left or right, it has to go inside the brackets, the square root symbol, the parentheses, whatever they are. So now I'm going to call this g of x. We're going to use function notation. Absolute value. And if I want to go left, then I'm going to say plus 2. So the absolute value of x plus 2. And then down 1, that should be outside of the absolute value symbol. I'm just going to go minus 1. That one's normal. So there we've just written a function for that. It's not too bad. Okay, now same thing for this one. We want to identify what's happening first. So you can see normally the square root function starts here in the middle at the origin, but it's been moved to the right 5 and down 2. So let's do that. Right 5, down 2. Okay, so in here, let's call this one h of x. We're going to do inside the square root symbol, we're going to go right 5, which should be x minus 5, right? Opposite of kind of what you'd think. And then outside of the radical, we're going to put minus 2. We're going down 2. But that should not be underneath the square root symbol. We call that a radical. And that's how we move translations and write their functions. Hopefully that makes sense. Good luck on the assignment. See ya.